Hi, my name is Emily Alcazar, and this is my CEE300 FE presentation on economics. Our problem statement. A self-employed engineer deposits $4,000 into a savings account at the end of every year for 8 years. She makes no deposits for the following 4 years. What is the balance in the account at the end of the 12-year period if the interest rate is 6% per year? Our visual for this problem statement will be a cash flow diagram. Cash flow diagrams are used in problem statements where there are several payments over a long period of time. As you can see, in this first 8 years, there will be 8 annual deposits, all with a value of $4,000. These arrows will be going in the negative direction because that represents that money is deposited into her savings account. As you can see, for the following 4 years, there aren't going to be any deposits made. This 12 represents our future value that we are looking for, our unknown, which is obviously going to be greater than these values. This arrow is in the positive direction because what would that amount be in her savings account if she withdrew it right at the end of 12 years? Our equations used to solve this problem. We will first use a uniform series compound amount equation for the future value at the end of the 8 years, where f is equal to a multiplied by 1 plus I to the n minus 1 over I. To solve for the future value at the end of 12 years, we will use our single payment equation, where we will use our new present value as this future value at the end of 8 years and compound it for the next 4 years. Even though there aren't any deposits made in the last 4 years, the interest is still being compounded annually, so it will still have an effect on that future value as it is in the savings account. So f is going to be equal to p, our future value at the end of 8 years, multiplied by 1 plus I to the n. Our variable definitions are pretty straightforward. F is equal to our future value, A is our uniform amount per interest period, or annual payment, P is our present value, I is our interest rate, this has to be in decimal form, N is our number of periods compounded. Our periods in this example will be in years. The interest rate was also defined per year, so this will not have to be edited. Our variable values. F is our unknown. This is what we are looking for at the end, for the future value at the end of the 12th year. A, our payment is $4,000 for the first 8 years, and our interest rate, as stated in the problem statement, is 6%. To solve this problem, we will use this first equation. The future value at the end of 8 years is equal to $4,000, our annual payment, 1 plus our interest rate to the number of years, minus 1 over our interest rate, which is equal to $39,589.87. To solve for the future value at the end of 12 years, we will use this as our new present value, multiplied by 1 plus 0.06 to our numbers of years, 4. And that will get us $49,981.30, which is the future value in the savings account at the end of the 12th year, which is our answer.